The high-voltage bushing is one of the most critical structural components of the transformer, reactor, or oil circuit breaker, ensuring their reliable, failure-free, and long-life operation. Internal insulation is the main structural part of the high-voltage bushing, defining its technical properties and performance. Nowadays, a solid RIP insulation is its most advanced version. Compared to others, bushings with this insulation are highly reliable and durable due to low dielectric losses and partial discharge factor, as well as to its thermal resistance. Isolator has been successfully developing and producing RIP bushings of up to 800 kilowatts for over 15 years. Mass use of these bushings in Russia and in the power industry of other countries shows that bushing installation on equipment is an essential stage ensuring its successful operation. Due to design features of RIP bushings, this procedure differs significantly from equivalents with other internal insulation types and requires an accurate studying and strict observance of all manufacturers' instructions. This is a video instruction on the installation of different types of Isolator high-voltage RIP bushings. Installation of a circuit breaker RIP bushings. This video part demonstrates a detailed procedure of 110 kilovolt bushings installation on oil circuit breaker carried out by Moscow United Electric Grid Company experts. Installation of external porcelain insulation bushings filled with transformer oil will be shown. Bushings with other types of external insulation are installed in a similar way. Video contents: RIP bushing design, slinging a bushing package, unpacking and removing the bushing, examining the bushing exterior, setting the bushing vertically on a stand, internal insulation check, installing the bushing on a circuit breaker, post-installation tests. Conclusion: circuit breaker RIP bushing design. The bushing comprises the following structural components: a solid insulation core, where the insulating paper is wound around the central pipe and impregnated with resin. RIP insulation as such. Wound paper is divided into layers by means of conductive plates in order to level up the electric field. A conductive rod inside the central pipe. A coupling mounted on the insulation core. A test tap linked electrically with groundable plates of insulation core. A mounting flange intended to secure the bushing on equipment. The flange is fitted out with eye bolts. External porcelain insulator filled with transformer oil or dry filling. External insulation can also be polymeric. A shielded tightening device in the top of the bushing. A contact terminal for bushing connection to lead. Lower shield for connection to arc suppressor. The bushing coupling carries a corrosion-resistant nameplate. The nameplate indicates manufacturer's trademark, bushing drawing code, bushing type, bushing weight, serial number, date of manufacturer, technical standard number. Take a look at the unique serial number of the bushing. It has been made by means of punch marking. That is why, in case all other data are lost, this number will help restore all the bushing information required, starting from its date of manufacture up to factory acceptance testing results. Slinging a bushing package. Let us proceed to the high voltage bushing installation, namely to handling operations. Before unpacking the bushing, make sure that handling equipment can carry the item weight and is in order. Slings meet necessary specifications, are certified and intact. Slinging of bushing packages and bushings themselves, as well as their handling, shall be carried out by personnel qualified in terms of occupational health and safety. A bushing package shall be slung as marked on the side of the box. To tie up the bushing package correctly, lead a sling under the box bottom and secure it to a crane hook on one side first and then on another. Slightly hoist the box over the floor and make sure it is balanced. Only then the package can be moved to a necessary place. Remove sealing tapes and a box cover by loosening the self-tapping screws securing the cover to the sideboards. Based on bushing dimensions, the cover can be made of one or more plywood sheets and, if necessary, it can be used for packing a bushing later again. For that purpose, we recommend keeping the cover screws in an intended place. Check for supporting documentation attached to the sideboard of the package. The documentation set includes Certificate of Conformity, Operation Manual, Packing List. Check the bushing completeness against the packing list. Carefully read the bushing operation manual. It describes main procedures of bushing unpacking, installation on a circuit breaker, and in-service maintenance. The manufacturer warranties reliable and failure-free operation of the bushing within the entire service life only if all the instructions of the operation manual are met. Study the schemes of bushing slinging, removal out of the package, and vertical positioning. Check for supporting documentation. Read the bushing operation manual. Study the bushing slinging schemes. Sling the bushing as marked on the package. Unpacking and removing the bushing. Remove polystyrene foam supports off the bushing top and put them in a stable place next to the package. These will be used for setting the bushing horizontally after removal. Release the bushing from all the fasteners inside the package. Tie up the bushing using handling appliances on the coupling. These may be represented by lugs or eye bolts of required capacity. Tie up the bushing using soft slings to avoid damage to porcelain housing according to a scheme shown in the operation manual. Smoothly lift the bushing over the package to a minimum height and make sure it is leveled. If not, put it back in and tie up the bushing using other sheds of the housing. Only then the bushing can be removed out of the package and handled further. Put the bushing down with the porcelain housing resting on the polystyrene foam supports taken out of the package earlier. When setting the bushing horizontally, make sure it rests on the same points as in the package. Remove the shipping cover from the bushing bottom by unscrewing the bolts, securing the cover to the mounting flange. The cover protects the bushing bottom against mechanical damage during transportation and storage. Also, remove polyethylene casing and silica gel bags protecting the bottom part against moisture. We have had a look at unpacking and removal of the bushing out of the package. Let us go through the key steps again. Tie up the bushing using handling appliances. Tie up the bushing top between the second and fifth sheds of the housing. Examining the bushing exterior. Examine the bushing closely for any porcelain housing and bottom damages. Pay special attention to housing cleavages. None should be found since any porcelain crack or cleavage might extend later and completely destroy the external insulation, leading to the bushing failure. Bushing components shall be free of oil leaks and damages. The bottom may contain a small quantity of oil left after factory testing. It does not indicate an oil leakage. If necessary, measure dimensions of the bushing units and components, although it is optional. While being manufactured, the bushing is subject to multi-stage inspection, and the manufacturer guarantees its conformity with relevant regulatory documents. Wipe the bushing bottom and the mounting flange using a cloth wetted in an anhydrous solvent. This procedure shall be done before measuring properties of internal insulation of the bushing in order to obtain accurate results. Before setting the bushing to a vertical position, insert a rubber gasket into a mounting flange groove. Thus, we have examined the bushing exterior. Now let us follow the key steps again. Examine the bushing for any porcelain housing and bottom damages. Clean the bushing bottom and the mounting flange. Insert a rubber gasket into a mounting flange groove. Setting the bushing vertically on a stand. Set the bushing vertically. This procedure is especially vital as there is a risk of damaging the bushing bottom. However, if specific rules are followed, this operation will be easy to perform. To tie the bushings up, lead 2 soft slings along the porcelain housing up to the coupling. Tie these slings with an additional sling between the second and the 5th large sheds of the porcelain housing. Tie up the slings using the handling appliances on the coupling, lugs or eye bolts. Tighten the slings along the housing and secure them, preventing their slipping, having wound an additional sling around each one of them. If necessary, secure these additional slings to avoid slippage. Place a proper soft material under the bushing bottom, rubber or felt. Avoiding the bottom slippage, smoothly set the bushing vertically on a process stand. We have just seen how to set the bushing vertically on a stand. Let us go through the key steps again. Lead 2 soft slings along the porcelain housing up to the coupling. Tie these slings with an additional sling between the 2nd and 5th large sheds of the porcelain housing. Tie up the slings using the handling appliances on the coupling. Tighten the slings along the housing and secure them. Place a proper soft material under the bushing bottom. Set the bushing vertically on a process stand. Internal insulation check. Perform bushing measurements. While carrying out electrical measurements to estimate a technical condition of the bushing, follow safety regulations for the operation of power plants of electric power stations and substations, and safety regulations for power plant operation. Internal insulation of the bushing is measured in several steps. The first step, measure the test tap insulation. The surface of the test tap insulation to be measured shall be dry and clean. Measure the test tap insulation resistance using a 2500 volt megameter. The final value of the insulation resistance, continuity, shall be 1000 meg-ohm minimum during commissioning and 500 meg-ohm minimum during operation. The second step, measurement of capacity and dielectric loss tangent of the main bushing insulation. Attention! Do not measure capacity and dielectric loss tangent of insulation between the last plate and the coupling, since the voltage applied may damage the test tap unit electrically. Bushing measurements require certain experience in handling measurement tooling, configuration, and interpretation of measurement results. Partially, it depends on the fact that capacity values are relatively small and may be distorted even under the effect of environmental spatial factors, as well as the bushing position inside transformer may also impact on measurement results after installation. Measurement results of the dielectric loss tangent are also dependent on humidity, weather conditions, and other factors. Correct measurements and assessment of results allow ensuring efficient operation of the bushing within its entire service life. Based on many years of experience in RIT bushings production and in-service monitoring, it is possible to confirm that a slight increase in dielectric loss tangent by less than 0.2 against the value measured during factory acceptance testing does not mean that the bushing insulation is damaged or not fit for operation. The maximum increase in the main insulation capacity amounts to 5% of the value measured during commissioning. Values of capacity and dielectric loss tangent achieved during acceptance testing are given in the bushing certificate. Let us consider such an important procedure as the correct grounding of the test tap. Grounding shall be made using a special multi-contact connected to a test tap hood with a wire. The hood ensures tightness of the test tap cavity and protection against mechanical damages, whereas the wire prevents loss of the grounding multi-contact. To underground the test tap, unscrew its hood and remove the multi-contact off the test tap pin. It will ensure the test tap undergrounding and the possibility of internal insulation measurements. After necessary measurements are done, the test tap shall be grounded again. Otherwise, once the high voltage is applied to the bushing, the ungrounded pin of the test tap will have a voltage equal to 50% of the voltage applied to the contact terminal, which will surely damage the test tap, leading to complete failure of the bushing. In order to ground the test tap, install the multi-contact so that the pin would enter a central hole of the contact and a spring-loaded contact would match the test tap hole. At this moment, visual and instrumentation monitoring of the ground reliability can be done, although there is no need in this procedure when the multi-contact is installed correctly. Afterwards, screw the test tap hood on manually, pressing on the rubber sealing ring on the test tap body. This quick, however demanding procedure of the test tap grounding shall allow eliminating one of the main causes of high voltage bushing damage. Thus, we have checked the condition of the internal insulation of the bushing. Let us go through the key steps again. Measure insulation resistance using a 2500 volt meg ohm meter. The bushing insulation resistance shall be 1000 meg ohm minimum during commissioning and 500 meg ohm minimum during operation. Do not measure capacity and dielectric loss tangent of insulation between the last plate and the coupling. Ground and seal the test tap after measurements. Installing the bushing on a circuit breaker. After all necessary measurements are done and the bushing is proved as meeting its certificate specifications, it can be installed on a circuit breaker. Prepare a bushing mounting seat on the circuit breaker. The slinging is made based on the necessity of bushing tilting at an angle corresponding to an angle of the bushing installation on the circuit breaker. Before installing the bushing onto a circuit breaker tank, check the position of the rubber gasket inside the mounting flange groove. Carefully bring the bushing to the circuit breaker and align it properly with an installation point on the circuit breaker. Mate the bushing flange holes and the circuit breaker tank pins and carefully install the bushing. Tighten the mounting flange bolts evenly around the circumference, avoiding over-tightening of separate fasteners. After the bushing has been secured on the circuit breaker adapter, install and position a contact terminal. After that, check the bushing connection inside the tank, correctness of assembly, installation, and adjustment of the arc interruption chamber. Make sure the bottom of the bushing insulation core and lower shield are free of mechanical damages which could have occurred while installing the bushing on the circuit breaker. Assemble, connect, and adjust arc interruption chambers and other internal components as per figures, strictly following the requirements of respective sections of the operation and/or repair manual for a specific circuit breaker type. Now we have installed the bushing bottom. Let us follow the key steps again. Tighten all the fasteners properly. Assemble and adjust arc interruption chambers in strict compliance with requirements of the operation manual for a specific circuit breaker type. Post-installation tests. After final processing, the circuit breaker is subject to electrical tests as well as testing of the bushing to a scope and using a technique specified by the bushing manufacturer. Electrical tests of the bushing after installation shall be performed by electrical laboratory experts to a scope and as per the procedure of pre-installation tests. It is to notice that in order to avoid voltage of over 1 kilovolts at the test tap and the last bushing plate when measuring a group of bushings and applying a test voltage of 10 kilovolts to terminals of group bushings, the test tap can be ungrounded only on the bushing, which is to be measured. Upon completion of operations, the electrical laboratory experts shall make sure all the bushings are provided with grounding elements and the test tap hoods are tightened until compression of the rubber seal. Based on values of parameters to be measured, a conclusion is made with respect to bushing operability. Later on, these values will serve as a reference for the definition of an actual condition of the bushing. In case testing results are positive, a relevant entry is made in the bushing certificate with an indication of installation completion date and signature of a person in charge of installation, and a technical report is drawn up. Thus, we have reviewed post-installation tests. Let us repeat the key steps. Test tap can be ungrounded only on the bushing being measured. Parameter values obtained serve as the basis for the definition of an actual condition of the bushing. In case testing results are positive, a relevant entry is made in the bushing certificate. Conclusion: correct installation and measurements provide a reliable basis for further long-term and failure-free operation of the bushing. That is why this process must be handled with special attention under strict observance of all instructions mentioned in this video. If any questions on bushings installation and operation, please contact the Isolator plant.